Okay, here we go. So I am going to share my screen and we are going to go through the Chapter 6 FRAPPY rubric. So if you have not done your FRAPPY yet, you're getting a sneak peek on the answers. It's okay. I personally think that you get the most benefit out of these kinds of conversations from doing the FRAPPY first and then coming to hear about the solutions. But I understand that we probably don't all get there, and that's okay. It's not a big deal. But I do want to go through the rubric. Can you guys read that okay? Can you see it, or is it like really small? If I go sideways, is that better? Is that better?
Yeah, I mean, it was fine both ways.
Okay.
Good now, though.
It's good now? Okay. I'm going to do it this way because, good. Okay. Because I can write a little bit better now that it's sideways. Okay. So the way this typically goes is I will go through the model solution first. And again, model solution doesn't mean that that's exactly what your solution looks like. It just means that's the model solution. So we've learned now in statistics that there's tons of different ways to write things and they're all correct. So, you know, the model solution may look a little bit different than yours. It's okay. So I'm going to go through the model solution and then we will go through the A, B, C, and D. It's 4 parts, right? Yeah, it's 4 parts. We will go through A, B, C, and D and talk about the E, the P, and the I. And remember, E is essentially correct, P is partially correct, I is incorrect. So you get a point, a half point, or no points based on your E, P, and I. So the question here was, you're looking at Buckley Farms. Buckley Farms produces homemade potato chips that it sells in bags labeled 16 ounces. The total weight of each bag follows an approximately normal distribution. Key phrase for you, with a mean of 16.15 ounces and a standard deviation of 0.12 ounces. Part A was, if you randomly select 1 bag of chips, what is the probability that the total weight is less than 16 ounces? What's the probability you got ripped off? That's the question. So it says it's a 16-ounce bag. The mean weight of the bag is even a little bit higher than 16 ounces. It's 16.15, so that's great. So what's the probability you got a bag that was underneath 16 ounces? Okay. Key phrase for you that you saw up at the top was, and I think, sorry, you guys. I need to get this in Notability so I can write on it. Send a copy. My bad, pause. I always forget this step. I don't use Notability very often. Create new note. Sounds great. Import. Done. Now I gotta come over here and find you. Does Notability work? Oh yeah, it does. Okay, good. I was wondering if Notability worked when you were holding your iPad sideways, but it does. So that's good. Okay, here we go. Sorry. Resume. Okay, so really key phrase for you was the fact that it was a normal distribution. So what they did here, and I try to, when we go through these FRAPPYs, I try to speak about them in terms of what College Board will look for. Not just what's a right answer or a wrong answer, but like what are the elements that College Board is going to grade you on? And some of these things you may not have thought of in terms of just taking a chapter test in my class, but doing the actual AP exam is a little bit different. So notice the first thing that they said in the model solution, they named their variable. Okay, important. The variable is not named in the context or in the main description of the question. So they said, let X equal the total weight of a bag of chips. Key. So they named their variable. That was a key thing. The other thing that they did that is key, but I'm not sure it's totally necessary if you draw the picture, which I'm going to suggest you all do. Hi, Gavin. Thanks for joining us. They did restate the fact that X is a normal distribution with a mean of 16.15 ounces and a standard deviation of 0.12 ounces. That's the describe the distribution. They gave you the shape, the center, and the spread, all in that one sentence. So whenever you are talking about a distribution, that's kind of an important sentence to list out. The other thing that they did, they gave it to you in context of the question. They gave it to you as 16.15 ounces. Standard deviation was 0.12 ounces. Again, important. The College Board will look for context. They want labels. They want to see things like that. Okay, so then they state the question. We want to find the probability that X is less than 16. They put that probability in notation. Also good. College Board likes to see notation. I highly recommend that you draw a picture. Draw a picture. The reason I really recommend that you draw a picture is because I have a feeling a lot of you will not do the Z-score. Am I right on that? I have a feeling, and it's okay, you're allowed to. I have a feeling most of you are going to default to your calculator. You're going to use normal CDF, and you're going to plug all these parameters into your calculator. When you do that on the AP exam, when you plug things into your calculator, there's two things that are really important. The College Board is not going to take normal CDF, number, probability. They're not going to. They're going to give you a P for that automatically, even if it looks correct. So when you use your calculator, there's two things important. One, draw the picture, because that shows them that you understand what a normal distribution looks like. You understand where those parameters go. So you can see on here, they have 16.15 marked. They labeled their graph, okay? The weight of the bag, and they put in ounces in parentheses. Again, context, that's really important. This guy right here, I wanna talk about this little set of parentheses right here that they have as part of their graph. That capital N stands for normal. So what this little set of parentheses says is, this is a normal distribution with a mean of 16.15 and a standard deviation of 0.12. That's what that set of parentheses says right there. Now, if you have this, you don't necessarily have to do that restatement at the top of your answer. If you did not take the time to write out X follows a distribution with a mean of 16.15 ounces and a standard deviation of 0.12 ounces, but you put this and you labeled the graph with the context, you've got all that information in the graph. You've got your shape with the capital N. That tells you normal. You've got the mean, because when you write out normal distribution, that's your first value. You've got the standard deviation, that's the second value. So there's your shape, your center, and your spread, all in that little notation piece. The other thing is you've got the context because of the label of the graph. Okay, so mind blown. If you don't write out that first sentence, it's okay, as long as you have all those elements that I put in blue. You have to put the capital N because that stands for normal, and you can use notation. Notation is appropriate on the AP exam. You're allowed to do that, okay? But I highly recommend that you draw the picture. Drawing the picture is going to be really important. And again, I'm willing to bet that a lot of you will not do the Z-score. Some of you might, and that's great. You do the Z-score, great, good for you. But normal CDF on your calculator works great, as long as you label that lower bound, upper bound, mean, standard deviation. So you have to label those four pieces in your write-up of your normal CDF calculations. Okay, so they used the Z-score. Either way, you get to this probability, 0.1057. They rounded it and said there is about an 11% probability of randomly selecting a bag that weighs less than 16 ounces. So that is an important statement because of the conclusion. Okay, that's like your conclusion of the work that you just showed. Okay, cool on part A. And again, this is just model solution. We haven't talked through EP and I yet, so hang tight. Okay, part B, model solution for part B. So let Y, oh, sorry, I should read part B. Part B says, if you randomly selected 10 bags of these chips, what is the probability that exactly 2 of the bags will have a total weight of less than 16 ounces? Okay, so if you think about chapter 6 was all on binomial distributions and geometric distributions. Well, there was a lot of other stuff at the beginning too, but this gets into the binomial versus geometric. This is a binomial setting. The reason this is a binomial setting is because you have a fixed number of trials. You're selecting, or you're using exactly 10 bags. You have a fixed number of successes. You're seeing how many, or what's the probability you get 2, exactly 2. You know that they're independent from each other. One bag doesn't affect the next, okay? And yeah, you can get into the binomial probability here. Okay, so they define a new variable. The reason I bring that up is because they define a new variable. So let y equal the number of bags that weigh less than 16 ounces. So here's your new variable. Now you're talking about the binomial setting. So y follows a binomial distribution. That phrase right there is important. College Board is going to want to see that you recognize that. Y follows a binomial distribution. The number of trials is 10. The probability of success on each trial is 0.1057. Do you remember where we got the 0.1057? That came from part A. So the probability of success on each trial comes from part A, which gets tricky too, because whatever answer you get in part A, you have to use in part B. So we'll talk about that for a second too. Then it says we want to find the probability that y is equal to 2. So now they just plug it into the binomial formula. And by the way, the binomial formula is a formula that's given to you on your formula sheet for the AP exam. It's not what you have to memorize. You just have to know when to apply it, which is sometimes harder. But you don't have to have the formula itself memorized. You will get it on your formula sheet. So you've got that combinations of 10 choosing 2. Then you've got the probability of success raised to the number of successes, which is the power of 2. Then you've got the probability of failure. Remember, that's 1 minus the probability of success raised to the number of failures. So raised to the 8th power. If you have 2 successes, you have 8 failures for a total of 10 trials. You plug all that in and you get this answer. Okay, once again, some of you may not use the formula. Some of you may plug it into your calculator. We talked about a way to plug it into your calculator. If you used binomial CDF, okay, no, sorry, in this case it's binomial PDF because it's exactly at 2. Sorry, it's not cumulative 2, it's exactly at 2. Make sure you label those. Trials, 10, you know, etc. Successes, or whatever, 2. Probability of each success, 0.1057. Okay, so up here in part A, you could have used normal CDF and then labeled lower and your whatever all the way down. Down here in part B, you could have used binomial CDF, but make sure you label. This is the part they're going to look for. Label the lower bound, label the trials, label your stuff. They want to see you label their stuff. If you don't label your stuff, I can promise you, you will get a P. Okay. Then they do the concluding statement where they just state basically, what is all the work that I just did? All the work that I just did tells me there is about a 21% probability that exactly 2 out of 10 randomly selected bags weigh less than 16 ounces. Notice that they say the probability, they say exactly 2 out of 10, that gives you the successes in the trials, and they put it in context, weigh less than 16 ounces, they label it. There's a good conclusion, okay? All right, moving on. Model solution for C. C gets tricky. C tests your knowledge of combining things. So Buckley Farms ships its chips in boxes that contain 6 ounces. The empty boxes have a mean weight. The empty boxes have a mean weight of 10 ounces and a standard deviation of 0.05 ounces. Calculate the mean and standard deviation of the total weight of the box containing 6 bags of chips. Okay, so you've got a box that has weight to it and also 6 bags of chips inside, which have weight to them. And you are supposed to calculate the new mean and the new standard deviation. Okay, so here's where your knowledge of combining things is tested. For now, they have more new variables. And it doesn't matter what variables you give this stuff, you guys. It's okay. Like, it doesn't matter. I'm going to make my pen a little bit thinner. I feel like it's kind of hard to write with. Okay, so let B equal the weight of the box and C be the combined weight of the box and 6 bags of chips. There's their 2 variables that they named. So C is going to equal B plus, there's your 6 bags of chips. Remember, X was already defined, and you don't have to redefine it. If you defined it up in part A, it carries all the way through. Unless you change it, then you have to define that. But if you defined it in A and you're still using it that way in C, it still carries. Okay, so you've got B plus X1, X2, X3, X4, X5, and X6 all added together. Okay, mean is easy. Mean is exactly what we envision it to be. Add them up. Okay, the mean of the combined weight is going to be the 10 from the box and the 16.15 for each bag of chips. Some of you may write that out as 16.15 times 6. Both are fine. Notice they put it in context. They've got 106.9 ounces label. Standard deviation is where it's trickier. Okay, because the standard deviation is not just a plain old sum. The standard deviation is the sum of the variances. So that's where you have to check yourself. You're not just adding up the standard deviations. You have to add up the variances and then take the square root. So they list it as that. You don't really have to call it the variance if you don't want to. You could throw a square root over this and just call it the standard deviation from the beginning. It doesn't really matter, but they start with variance. So they say the variance is, notice that it says standard deviation squared of the combined variable, the combined standard deviations, and then they've got all their standard deviations there, squared. So the 0.05 squared, that comes from the box. That was given to you in the question for the standard deviation of the box. Then you've got the 0.12 squared, 0.12 squared, 0.12 squared, 0.12 squared, 0.12 squared, 0.12 squared. I would not do those and multiply by 6. I would just be safe and write them out. Whatever, that's just me. Okay, so you get your variance of 0.0889. The standard, then they continue on and say the standard deviation, notice the square is gone, is they show you that they're taking the square root of that, and here's your answer. Okay, so they're testing your knowledge in this question of being able to combine means and standard deviations. Combining means is easy. Combining means makes so much sense in our head. You just take the means and add them up. When you are combining standard deviations, you can't just add the standard deviations. You have to add the variances and take the square root. Okay, one more model solution to go through for part D, and then we'll talk through the scoring. So in part D, I'm trying to blow that up a little bit. Okay, so in part D, let me read you the question because some of you may have not done this. So Buckley Farms decides to increase the mean weight of each bag of chips so that only 5% of the bags have weight that are less than 16 ounces. Assume that the standard deviation remains 0.12 ounces. What mean weight should Buckley Farms use? Oh. This is a mind-blowing question because you have to work backwards. This is an inverse norm question. So couple of things you know it's a normal standard, you know it's a normal distribution. Draw your normal curve. Drawing out the picture helps so much, you guys. So draw your normal curve. Mark what it is you're trying to find, okay? You want 0.05, so they have their area marked here. You can see they've got their normal curve. They have the area of 0.05 marked, and they want this to be the 16 ounces. That's what they want. They want 16 ounces to be the marker where only 5% is less. And the question is, what is this going to be? Okay, so here's where things get a little bit tricky. So here's how they do their model solution. Let X equal the total weight of the bags of chips. We already defined X. They put it again, but you don't have to because you're using the same X. X follows a normal distribution with a mean M that you don't know and a standard deviation of 0.12. We want to find M such that the probability of X being less than 16 is equal to 0.05. Okay. So if this were a normal CDF question, here's what it would look like. You would have the lower bound of negative infinity. You'd have the upper bound of 16. You'd have a mean of something you don't know, and you'd have the standard deviation of 0.12. So this is the question. This is what you're finding. That's the piece that's missing, and that's different for us. We don't normally look at it that way. Now, they do this in terms of a z-score. So I'll show you what it looks like in a z-score. If you think back to z-scores were where we would normalize our data to that z-table. Let me show you that z-table. Mine is yellow. You have the z-table in the back of your textbook. That's where you guys saw your z-table. I have these bright yellow ones laminated for when you guys take tests in our classroom. You can use these. So this is that z-score table. If you think back to the z-score table, you have the under 50% are negative z-scores, over 50% are positive z-scores. Those are on the two different sides of the table. The z-score formula was this. Your formula looks like Z is equal to data minus mean over standard deviation. So in this case, you're missing the mean. Okay, that's the piece you're missing. But the thing that you have to do before you can plug things into the formula is you have to take your probability of 0.05 and you have to figure out what its z-score is on the z-table. So that's where we would look in the body of the table and we would find 0.05, and then we would see what z-score corresponded with that value, that 0.05 value. So they did that work here, and they found that the z-score that corresponds with an area of 0.05 as according to the z-score table, which, by the way, this is another tool that you have on your AP exam. This will be in your resource book, in your test book, in all the resources. So they found that an area of 0.05 corresponds with a z-score that's negative 1.645. Okay. They plug that into the z-score formula. So there's your z, there's the data that goes with that z-score. You want the 0.05 to correspond with 16 ounces. There's your standard deviation, and here's the thing that's your question. And now you're just using algebra. Multiply both sides by 0.12, subtract your 16, divide by -1, you get your M. That's a hard one. That's a very much working backwards one. And that's one that you almost have to use the z-score calculate. It's easiest to use the z-score calculation to figure it out. Okay. So then it says so then they do their little conclusion statement. Buckley Farms should use a mean weight of about 16.2 ounces because that's what they found there to make sure less than 5% of the bags are underweight. Okay. Ooh, toughie. Okay. That's just model solution. We're done with the model solution. That was a hard one to talk through. When I told you that chapter 6 was hefty, I wasn't lying. Okay. So now we're going to go through the scoring, and hopefully that will go rather quickly, but we'll talk about the scores. So 4 parts, A, B, C, D. Each part is going to be 1 point. You get 1 point for an E, you get a half point for a P, and you get no points for an I, and then you just add your score up at the end. So for part I, it says it's essentially correct if the response includes the following 3 components. Indicates the use of a normal distribution. That's what we talked about with that opening statement. Clearly identifies the correct mean and the correct standard deviation. It doesn't explicitly say this, but they want context. Put it in context. Okay, so that's your first component. Uses the correct boundary value. That comes from that graph. This right here. Uses the correct boundary value. That's what they mean. So they want to see that you marked off your boundary, you shaded the correct direction, and you labeled what that value was. That's what they want to see. And then the third component was reports the correct normal probability consistent with components 1 and 2. So then you report that probability of whatever it was, the 0.1057. Okay, these 3 pieces. Now remember, if you use that notation, the capital N with the parentheses and the mean and the standard deviation, and you have a picture drawn, technically that's enough. Some people put that opening statement. You can or you don't have to. But if you don't, be very explicit about putting that notation. Capital N, inside parentheses, mean, comma, standard deviation. And then also labeling the graph with the context at the bottom. Also important. Okay. The partially correct says if you have any 2 of the 3 components listed above, if you have only 1 of the components or you did it wrong, then it's incorrect. Okay. Oh, they put a note here. It says, note, a correct z-score calculation is sufficient for components 1 and 2. There are some people who are very bold and never draw pictures. I don't recommend that. You can be bold and you can just show the z-score and show your calculations that way, but you have to be really clear when you write out your statements and things like that. There are a lot of things that are shown in a picture. So I always recommend to my students to draw the picture, but if you did the z-score calculation, you don't technically have to draw the picture. Okay? Okay. That's what that note means. And then they have other notes. It says, the following are additional examples of what clearly identifying parameters for component 1. Writes, mu, sigma, lowercase sigma. You could use the notations. Explicitly labels the mean and standard deviation in normal CDF. They say that you can put your normal CDF calculator, but explicitly labels is the kicker there. Explicitly labels. Sketches a normal curve. That's my recommendation. Labels the 16.15 as the mean, labels 2 additional consecutive values separated by the 0.12. So they say go out from there to label your curve. And then it says, another note, incorrect use of statistical. Yeah, if you use incorrect symbols when you're labeling things, they'll knock you down to a P. Okay. They do say it'll knock you from an E to a P, but not a P to an I. If you were already at a P, they'll still give you a P. But if you put if your symbols are incorrect, you will not earn an E. You can't earn an E. Sad panda. Okay. Moving on, part B. So part B, there's 3 components for part B. This is the binomial distribution one where you were combining the 10 bags of chips together. So it says, or you were not combining the 10 bags of chips. You had 10 bags of chips and you were looking for exactly 2 to be underweight. So essentially correct if the response has the following 3 components. Indicates the use of a binomial distribution, important. Clearly identifies the parameters of N and P, important. How many trials? What's your probability of each trial? Uses the correct value of interest, 2 successes, important. Reports the correct probability consistent with 1 and 2. Okay, there's your 3 components. And then partially correct if you only have 2 of the 3 components, and incorrect if it's wrong or you only had 1 component. Okay, here's all the notes. Correct use of binomial probability formula with number substitute is sufficient. Yay. So you can use the formula and write in the numbers, and that's sufficient for part A, or for the first component. The following are additional examples of clearly identifying parameters for component 1. You could write n equals 10, p equals that, or the other value from part A. We'll get to that in a second, to answer part A if it's incorrect. And then explicitly labels n and p in the binom CDF. So there again, they're telling you it's okay to use your calculator, and it's okay to tell us that you use your calculator as long as you explicitly label. Okay. And then it says the response 0.10575 to the second power, and then times 1 minus is blah, 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 scored as partially correct. Okay, so this is the binomial formula without doing the combinations in front, without the binomial coefficient, they call it. That would get a P. If you dropped the binomial coefficient off, you're not incorrect on the other pieces, but dropping the binomial coefficient would get a P. Okay, I want to go back to that probability. So this is one of those funky questions where the answer you found in A, you have to use in B. Well, what happens if you do A wrong? If you do A wrong and you use your answer from A in part B, but you do part B correctly, you will get a P. You don't automatically get an I, which is a good thing, but you can't earn an E. Okay? So if your part, see, now I'm second guessing myself. Now I feel like they might be able to give you an E for that part only, but you can't get a 4 on the whole question. I'm going to go back and clarify that on College Board. My point being, if you got the answer wrong in A, but you carried out that wrong answer correctly in B, they're going to give you credit for B. Okay? So don't panic. If you do part A wrong, don't panic that that means you're going to get the whole rest of the question wrong. That's not the case, because they treat these as separate components. So, and they score them separately. So if you use your answer for part A in part B, you can still get part B correct. I think that's what it is. I'm going to go back on my original statement. You can still get an E for part B only. You just can't get a 4 on the whole question, because obviously you got part A wrong. So you wouldn't get a 4 on the whole question, but you would get the points for part B. Hopefully that makes sense. Basically, it's a good thing. They're giving you the benefit of the doubt of being able to do the one part correctly, even though you used the wrong answer. Okay. Let's score C. So we'll go down to part C. So part C was the one now where you are combining, this is the one where you're combining the box and the 6 bags. Okay. It says essentially correct if the response correctly calculates the mean and the standard deviation, showing work for both calculations. Partially correct if the response correctly calculates the mean and standard deviation, but does not show work for both calculations. If you just list the mean and the standard deviation, but you didn't show how you got there, you'll get a P. You have to show your work. Or either the mean or standard deviation correctly with work shown. This is where you're forgiven. The standard deviation is the one that's hard to remember. You have to add the variances. If you do that part wrong, but you did the mean right, you'll get a P. You'll get a P because you did the mean right. So there you go. And then incorrect otherwise. So basically, do both calculations, show your work. That's it. Okay. Well, my lights went off on me. Hopefully you can still see me. I'll stand up and wave around. Okay, part D. We'll move on to part D. This is the tricky one. So in part D, here's your essentially correct. 3 components again. Indicates the use of a normal distribution and clearly identifies the correct boundary value and standard deviation. That boundary value of 16 ounces and the P of 0.05. That's what they mean by boundary value. Uses the correct z-score. They want a z-score calculation here. I know you guys probably don't use z-score very often because we have fancy machines that do most of the work for us, but they want a z-score calculation here. And then reports the correct mean consistent with components 1 and 2. So mark that 0.05, go to the table, find the z, plug it into the z-score formula, which, by the way, z-score formula is given to you on the formula sheet. It's not, you don't have to have it memorized. You will get it on the formula sheet. So plug it into the z-score formula, use algebra. You know, you're solving an equation for M. Use algebra to back your way out of that equation and get the mean. It says partially correct if it includes only 2 of the 3 components listed above and incorrect otherwise. Here's your notes. The expression, this right here, is sufficient for components 1 and 2. You don't have to state the z-score formula. You can go straight to plugging in the values. That's what they're saying there. And then here's the other thing. Acceptable z-scores include this. Here's why. This z-score, and I may have these backwards, but you know, we were looking for a probability of 0.05. The z-score for negative 1.64, I'm just going to look because I have it here. Here's the z-score for negative 1.64, 0.0505. Here's the z-score for negative 1.65, 0.0495. It is literally smack dab in the middle. This does not happen on the z-table very often. It is literally exactly in the middle of the two. So while this is not a z-score that's given to you on your table, the fact that this is exactly between those two, that means you can go exactly between those two. But what College Board is telling you is you can use either one of these, because technically what you would do is find the z-score closest to your probability. Well, those two z-scores are equidistant from our probability, which tells you that either one is correct. So College Board will take the fact that you picked that. They will take the fact that you picked that because technically those are both equidistant from your probability. Or if you recognize that it's cut in half, they'll take that as well because that's technically what it is. And that, by the way, you guys, you can still show the z-score formula, but you can also do inverse norm to find that exact z-score. If you put inverse norm, you can get it that way. Nope, sorry, I lied. Scratch that, take that back. Inverse norm requires the mean, and you don't know the mean. So never mind, ignore that statement. You have to use the table, that's why. So you have to use the table, you have to use the z-score. 0.05 is a tricky one because, not tricky, but 0.05 is a unique one because it's equal distance between two z-scores. So you can technically cut those in half and find its exact placement. That's what they're getting at there. Woo! We're at the end. How'd you do? Here's what they say. Each essentially correct counts for 1 point. Each partially correct counts for a half. You decide if you got closer to, if you're at a halfway mark, like if you're at 1.5 or you're at 2.5, you decide, am I closer to 2 or closer to 3? Was that a gimme P or was that a solid P? If that was a solid P, you can bump yourself up. Things like that. Okay. All right. I'm going to stop the recording and then we can chat. I can figure out how to stop the recording. Stop recording.